Live streaming is on.
Good afternoon, everyone. So today's session we are going live on YouTube also. We have a session today by Mr. Otnu Roy Chaudhary, who is an IoT evangelist and founder of Capsule Labs. He was a techno-functional consultant for blockchain, IoT, AI, RPA-led digital transformations, providing delivery and solutioning support to LTX global sales system. Prior to LTX, Otno was a member of technical staff at Infosys Tech Labs, Harvard Sensor Networking Lab, Telcordia Advanced Technology Solutions Lab, which is now Ericsson, and Blue Highway. He has postgraduate degrees in computer science from IIT Guwahati and Harvard University, and he is a senior member of IEEE and Computer Society of India. He has published over 35 papers and patents in the area of IoT and wireless sensor networks and provided consultations for over 100 IoT based solutions globally. And this is the eighth batch that we are taking with him. So, on behalf of NIELIT Kolkata, I take this opportunity to welcome you, After sir. So, once again, you are welcome. And
Thank you so much, Rashmi.
yeah, and we have participants from WBSC West Bengal, and we have participants from CDEC Pune and CDEC Noida. We have participants from defense also. So I welcome you, and we are very much looking forward to your lecture where you would be introducing the participants about the advent of blockchain in industry and where blockchain lies today. What are the current trends and technologies that are being used for the development of blockchain application? So over to you, and you may start your session now. And this session is going live on YouTube right now. Thank you.
Thank you. Thank you so much. Thank you so much, Rashmi, for the very warm welcome on this balmy August day, so as to put it, right? Thank you all to the participants who are joining in from all across the country, from various organizations, right? If any of you would want to introduce yourself, probably talk a little bit about which organizations you are representing, and if you have heard of a particular use case in your department, right? So that may help me contextualize my discussion a little bit, right? Would anybody want to take up the microphone and probably introduce a problem that they are looking at in their departments? I welcome Sukumar, welcome Marajus, welcome Randhir. So I see people from Chris Delhi, our very own West Bengal State Electricity Development Corporation Limited. Welcome Ramananda. Right, I see CDAC Noida is also being represented. Right. So overall, today's discussion, where I want to focus on, we have heard a lot about this new word called blockchain, to the point where each and every one of our departments are asking us to look at where we can use blockchain in our day-to-day systems. How can it bring value to our citizens? How can it make life easier for our citizens, right? And we are being tasked to identify use cases where blockchain can be used, right? So blockchain is a security security solution at a very high level. And whenever you are talking about a security solution, it is very fundamental to understand where is that security coming from, right? When you when you buy a lock for a padlock for your for your door, you look at the quality of metal, right? You look at how strong that particular padlock is and whether it suffices for your requirements, right? And the same kind of goes for blockchain as well, right? So we have to understand, if we are considering this as a security solution, then what is it that is driving the security of blockchain systems? And that is what we are going to basically cover in today's session. But if you any of you have a problem statement or a particular use case, it would definitely help me contextualize, right? Today's session, I call it a game of transactions because at the end of the day, we want to be able to secure our, the transactional data, all the interactions that are happening between multiple parties, right, into into a secure system. So the first session, I'm going to focus on that today, and tomorrow we are going to take a deeper dive into India's blockchain strategy and look at a number of use cases there, financial as well as non-financial use cases as well, where the blockchain technology can be used, right? So that said, this session is being organized for government officers. So we have to look at blockchain not in isolation, but we have to look at blockchain as part of what else is going on in India, right? And we have to look at blockchain as really being part of the other systems, other IT systems that have been built and are being managed by the government itself, right? So at the forefront, there is a very big initiative called, it's an e-governance initiative called Digital India, right? Bringing a lot of departments online, making the citizen services or bringing the citizen services online, so that it reduces it reduces the friction between having to go and visit a visitor office. A lot of processes have already been moved online today, but that's not the end of the road. There are still many processes which can be brought online, right? So that's one set of initiatives around Digital India, right? The next major initiative is around our eKYC, our Aadhaar initiative. It's a unique identity. It's the Aadhaar is essentially UIDI manages the world's largest biometric database, right? And this biometric database becomes the basis for as a proof of identity, right? So we are starting to see a lot of Aadhaar enabled transactions, whether it is something that is used to draw rations, or tomorrow the Aadhaar card is, we incorporate Aadhaar enabled voting machines or not, right? So there is a lot of scope for bringing in this database or leveraging this database for providing citizen services, right? So that is why the Aadhaar system is very it's a very important aspect in what we do with respect to our citizen services, right? The third major piece to this puzzle is the UPI interface, right? The Unified Payments Interface, as is managed by the National Payments Corporation of India, right? And UPI has really enabled a lot of small value peer-to-peer transactions. Not it has still been mediated by banks and other payment corporations, but it has significantly increased the number of financial transactions that are happening, the number of cashless financial transactions that are happening across the country, right? So in many of these transactions that we are doing today, small value transactions, whether it is somebody buying a cup of tea, or paying for an auto, or paying their taxes online, right? We are seeing UPI as a very, very strong enabler of making these services digital, right? Now, all of these digital technologies that the government has really invested in, when they come together, they allow us to fundamentally change a lot of processes and make them much, much faster, right? Because this infrastructure is already available within the country, right? Now, one more piece to this puzzle is whenever there is a transaction, the government's role in that particular transaction is often limited to just record keeping, right? As we see in various kinds of registries, whether it is a land registry, whether it is a birth and death registry or motor vehicles registry. So in many cases, the government's role is just to maintain the records, and in some cases the government is also essentially taking it is looking at these transactions because there is a taxation component to this, right? A certain percentage of the transaction has to be paid as taxes, and as we all know, taxes enable the government to fund itself and fund all other projects, right? Now, even on the taxation part, with the introduction of GST, we have built a pretty large and stable GST network, a GST collection network, the GST network, right? This is also completely digital, and taxations can be incorporated by using the GST portal as well, right? So, three major parts: the government's initiative to reach out to the citizens, the government's initiative to create a virtual identity mechanism, its ability to facilitate cashless transactions, and to facilitate taxations, right? These are all very, very important pieces of infrastructure. Along with that, the government is also focusing towards enabling the technology leaders to participate in this transitionary process, right? And how are they doing that is because a lot of government services or public sector services, the interactions, the fundamental application programming interfaces or the APIs are being made available through a portal called API Setu, right? API Setu has all, right from your COVID booking APIs to taxation APIs to certification APIs for school records, college records, a lot of insurance payments, right? All of these APIs are being made available to the public so that they can now envision the world of technology leaders, technopreneurs can look at these APIs and kind of build their own applications and processes, complementing the systems that are already available, right? So these are going to be third-party applications. So API gives you a testing environment for building an app. It gives you access to a staged environment. But if you are deploying that app itself, you can get in touch with the respective departments and get a production license for using those APIs and building commercial applications as well, right? Now, in the context of all of this, what is happening is that there is exponential growth in the number of transactions, specifically in the number of digital transactions in the country, right? There is the number of transactions per capita is growing because there are multiple types of transactions that are now happening, right? Now, these transactions could be, me having a cup of tea at a local tea stall, right? Which is a human-to-human transaction that is being mediated by UPI-enabled apps, right? So this could be human-to-human transactions, or these could be machine-to-human transactions as well, right? Me interacting with an ATM machine, right? Multi-factor authentication, right? These are kind of systems which are machine-to-human transactions. So not only do we have the set of human to human and machine to human transactions, right? Today we are also witnessing transactions which are happening without the intervention of humans, right? We are starting to see machine to machine transactions as well as human to machine transactions as well, right? Each of these transactions needs to be recorded, right? Each of these transactions, whenever there is a transaction involving multiple parties and an activity, that is a record, and that record has to be managed. This is where blockchain is starting to come into the picture as being able to provide this kind of a secure mechanism in order to build this record keeping ledger, right? I'll come to that in a little bit, right? But to summarize your slide, what we have here is that as people are getting more internet connectivity, they are the number of people doing these transactions are increasing. As they get more comfortable in doing transactions, they are doing more and more transactions. So there is a multiplicative effect that is happening, and along with that, there are also other kinds of transactions that are happening without human intervention, right? And that is where machine to machine transactions, a large number of machine to machine transactions are also coming in, which must all be recorded, right? So this is one side of the story where there is a lot of transactions being created, right? Now, with transactions, there has to be a fundamental trust, right? That the transaction that is happening is being recorded, that the transaction is valid, that tomorrow, if we do a completely valid transaction, tomorrow, so one of the parties should not be able to come back and say that that transaction did not happen, right? So non-repudiation of one of the parties is not acceptable, right? However, if we consider the entire country and its financial conditions, right, one of the main basis of interactions in a particular country, of transactions in a country, is by mediating it through money, right, or currency. And that is where, for all this while, money has been something that is controlled by a central entity, by a central intermediary, right? Whether it is a public organization, right, or whether it's been mediated through the RBI or through the banks, right? There is a centralization with respect to the monetary policies within the country, right? As citizens, we fundamentally trust this system. We trust the government to do the right, holding the value of a currency in the international markets. Right? But even then, there are, when the country comes under pressure, there are known instances of the central entity taking unilateral decisions, right, which brings about massive shocks within the financial institutions, right? And that is where we see essentially a macroeconomic trust erosion, right, with this kind of a central entity. And the citizen is not this the general population is not necessarily prepared for these kind of unpredictable shocks to the very basis of their transactions, right? We have seen this when a country is in a wartime economy, and governments are not able to keep a hold over the inflationary pressures. We see hyperinflation starting to kick in. History tells us that it has happened in the past, so there is no reason to believe that it will not happen in the future, right? Governments have tried to address it by printing more money, and that has also led to some very, very extreme cases with for example, the Bank of Zimbabwe printing this $100 trillion notes, right? Which could hardly, I don't know, at one point it could buy you a loaf of bread, right? not only under inflationary pressures, but due to political leverage or due to political beliefs, this kind of shocks can also appear. And we have seen that in India as well with the demonetization policy, right? The government has the power to fundamentally change the way currency is handled, right? Because it is right now that currency is really backed by statute. It is not backed by by hard gold or some alternate source of value, right? But overall, the point that I'm trying to make here is that wherever there is an intermediary that is involved, especially when it comes to such large, the fundamental basis of how we do transactions, right? There is a big risk. There is a big risk of unilateral decisions which may not go down well with the population, right? Not only in the macroeconomic scenario, I gave you the example of the currency system because I wanted to bring in what happens you know mm, at the national level, right? But we see this kind of behavior even in microeconomic scenarios or even in smaller transactions, right? Which is why I titled this talk as a game of transactions, right? So let me introduce this talk and say that, well, all of us at one point or the other, or at least most of us, have played a game of Monopoly, right? Whether we call it Monopoly or business or Babshai or in whatever terminologies we use it. Did somebody have a question? No. So whatever word we use for it, we have all been, we have all pretty much witnessed this game. And this is a very, very simple game that has been, we have been playing for a while. And in this particular scenario, let me say that there are 4 players, Orun, Borun, Kiran, and Mala, who are playing this game. And the basis of this game is everybody rolls a dice and they go along. If they land on a place, they can make a transaction with the bank to buy a property, or if they land on a property that is already held by somebody else, then they have to pay some kind of a rent, right? So these are again small transactions, right? Micro transactions, if you will. Right. So let them all of them be playing the game of Monopoly. Mala is acting as the banker, so she has the Monopoly money with which she's dealing in this particular game, right? And just for the sake of keeping records, either we can keep the records verbally, or in this case, let us assume that Mala is writing down every record of every transaction that is being made, right? So if there is so she kind of maintains this communal ledger that everybody can look at, and she makes these entries, right? Mala pays 200 to Orun. So we have the parties that are involved and the activity, which is paying somebody 200, right? Or receiving some money as rent, right? Or some Monopoly money as rent. So a transaction essentially consists of parties and an activity that they have agreed on, right? So almost like a contract. I'll come to that in a little bit. So when I'm maintaining this ledger of transactions, the very basis, the reason disputes arise is because there is a conflict, right? So what if Mala is biased? What if Mala is biased and makes a false entry, right? That is what we are trying to avoid, right? Now, here I introduced 2 words. One is ledger and money, right? So let us take a deeper look in what does it really mean, what does a ledger really mean, and what should be the characteristics of a good ledger, right? So when we talk about a ledger, ledgers are really records of accounts for economic activities or for financial relationships, right? So that is why it has it has parties involved and the activity and the amount or something, right? And there are multiple types of ledgers, right? What do I mean by multiple types of ledgers? Well, I could go out for a cup of tea And I go to this one shop regularly, and I settle accounts at the end of the day. Right. So there is a verbal contract, or there is a verbal or a personal ledger that I'm essentially maintaining with the shopkeeper, where we have identified a protocol wherein we say that, okay, you keep track of whatever, how many times I've had tea throughout the day, and I'll come in and pay at the end of the day. So that is a personal ledger, and we have agreed on a personal protocol in order to make entries into that ledger, right? Even if the entries are verbal, right? But a financial institution or any other institution cannot take our words as the basis of a transaction, right? It has to be recorded formally, and the moment it is being recorded formally, there needs to be a payment system, right? So think of it like, you have an account with a bank. The bank has it kind of records every time you have made a transaction on that. And if you want to make a transaction, you need to go use your debit card, right? You need to go use your, write out a check to somebody, right? So these are all essentially payment systems. These are formal payment systems, and because it is a formal system, it has multiple checks and balances in this process, right? To ensure that the ledger is being updated in a consistent format, right? So the characteristics of a good ledger is that it should be immutable, right? Once I write something onto a ledger, I should not be able to erase that. That is why ledger entries are not made with pencils, right? They are actually either software transactions that get recorded onto a database, or it is written in ink, right? So that it cannot be changed, right? Uh, a ledger entry has to be consistent, right? I cannot mix up my debits and credits or use different notations for debits and credits. So it has, whatever protocol we assume, whatever format we assume, right? It has to be consistent based on that. There has to be a timestamp, right? When was the transaction done? Who is the owner of that transaction? Who is making that record, right? So that down the line, the owner cannot claim ignorance about making a record entry, right? It has to be accurate as far as possible, and there has to be a description of the transaction that is involved over here, right? Uh, Along with that, because we're talking about a financial system over here, we need to have a mechanism. We need to have a common understanding of that, a common understanding of the underlying money format, right? And money really is a value store, right? Something that can be exchanged for services, right? Now, in the context of the monopoly game that I introduced earlier, transactions within the game are valid using monopoly money, right? So this is what is called as a native currency, right? It has a scope that is valid within the context of the game, right? But I cannot go and pay my taxes with monopoly money, right? Because the scope does not extend at a national level, right? So the kind of currency that we can use at a national level is called fiat currency, right? And this involves anything you can pay your taxes with, right? It includes banknotes, coins, debts, bonds, legal tender. All of this are essentially value stores, and they have financial values. They can be used as money, right? They can be used as money in order to carry out a financial transactions, right? So therefore, the money also needs its certain characteristics, right? It should not get damaged very easily. It should be portable, right? That is why even though at some point coffee beans were used as currency in some countries, today we have moved to paper-based money, right? So it should be portable, it should be divisible and acceptable, right? So if I replace a 10 rupee note with two 5 rupee notes, they are equivalent. They are exactly the same in terms of the services that it can buy, right? So which is why money is divisible and it is acceptable, because everybody within the country will accept that local currency, right? So these are characteristics of money, and it should be stable, right? If it is not not stable and there is an unlimited supply of money, it will lead to the money being devalued and inflation kind of rising on top of that, right? So money has is something that has social and economic consensus. Right? Why I'm bringing this up is because while we saw that a money-based financial system at a national level is susceptible to macroeconomic stresses and macroeconomic decision making, native currencies are subject to essentially microeconomic trust erosion, right? And this happens when four people playing a game of Monopoly and one of them is cheating, right? That erodes trust. That also fundamentally erodes trust, not at a financial level, but it could be at a level of friendship, right? So even then, even in this small game, there can be a trust erosion that is happening, right? So what we need to do, if we can bring this trust, if we can create a cryptographically secure ledger, right, without any implicit trust requirement, that is essentially what a cryptocurrency really is, right? It is a cryptographically secure ledger, right, without implicit trust. That's the important part, right? Without any central intermediary. And incidentally, Bitcoin is just happens to be the first implementation of a cryptocurrency that addresses trust directly, right? How do I build trust among the stakeholders that there is a single source of truth, right? So the Bitcoin, when Bitcoin came out as the first cryptocurrency, right? The Bitcoin paper, and it's not very old. It's about what 10, 12 years old, right? This paper called Bitcoin, a peer-to-peer electronic cash system. It was introduced as a cash replacement system, right? And it was published under a pseudonym of Satoshi Nakamoto, right? A 6-page paper that fundamentally altered the way we look at transactions itself, right? And in the process, it solves a fundamental computational problem, what we computer scientists call as a NP hard problem. And therefore, because this problem was solved, we find equivalent classes or other areas where the same technologies that were used for developing Bitcoin can be used, right? If I read that abstract, it says that Bitcoin is a purely peer-to-peer version of electronic cash, uh, a purely peer allow online payments to be sent out directly from one party to another without going through a financial institutions. Digital signatures provide part of the solution, but the main benefits are lost if a trusted third party is still required to prevent double spending, right? So if I look into the abstract itself, it is introducing a lot of technology terms, right? It is bringing in peer-to-peer electronic cash. It talks about digital signature, timestamping, how you need to solve the problem of double spending that arises due to a mismatch of consensus, right? How do we create a proof of work, right? How do you create computation and essentially energy costs as a proof of work, right? Chain those proof of works together into a set of trusted transactions, right? Longest chains broadcast messages, right? So this is the foundation of blockchain. But the only non-technology word that you hear is no financial institution. Right? No financial institution here is, essentially implies that no unnecessary intermediary is required when two parties want to come together for a particular transaction. Right? The transaction could be financial, in which case we are talking about a cryptocurrency system, or it could be any other record that they really want to maintain, right? Any other record of activities that the two parties want to maintain securely, right? That is where I do not need to involve an untrusted and a central intermediary who I may or may not trust, right? So this is where Bitcoin comes into the picture. And the fact that we are using a chain of proof of work is essentially what manifests itself as a blockchain, right? When the first couple of years when after Bitcoin came out, we were looking at it as at primarily cash replacement, as the name itself suggests. It's a peer-to-peer electronic cash system, right? But as we found out the merits of the underlying technology, of the underlying blockchain technology that was invented to solve the cryptocurrency problem, right? We found that there are multiple uses of blockchain itself, right? Now, in my previous slide, I had introduced, when I talked about money, I had spoken about fiat currency and native currency, right? Money that is used, that is acceptable within a nationality, money that can be used for financial transactions, and play money, right? Native money that is used in the context of in a more limited context, right? Now, often what happens is this native money and the real money can actually be linked, right? And this comes out of different circumstances, right? For example, if I consider that Borun is Orun is losing in the game and wants to exchange 500 monopoly money for 100, for real 100 rupees, right? uh, Nobody can prevent this transaction, right? Because it is two parties that have agreed that they want to exchange money, that they want to go ahead with this exchange. There's nothing in the law which says that you cannot buy, you cannot go ahead and make this transaction. But in this process, what is happening is a demand is being created for native currency, and there is now a market price, there is now a exchange rate that is getting established between the native currency and the fiat currency, right? Cryptocurrency exchanges, we have seen them come up over time because the virtual money, right? The cryptocurrency has been linked with real money, right? And there are now exchanges where you can either buy cryptocurrency with dollars, with local, with currency, and you can exchange that as well, right? There are Bitcoin ATMs available as well where you can make withdrawals as well. It is still not legal in India, but some of the other countries, this policy has been enforced, right? So there is nothing really stopping us. The moment you have created this value system, essentially this native currency, there are going to be exchanges through which you can switch between native currency and fiat currency. Another thing that is happening here is when we are making, when if you go and look back into your passbook, right, that the bank has issued, it records the set of transactions where there was a debit or credit to your account, right? And typically these debits and credits are they are spread out so that there is a very clear demarcation between between transactions that happened on your account. However, as we see an increase in the number of transactions with UPI and all of that, uh, the rate at which transactions are happening are increasing, right? And there are way more transactions now. A lot of these transactions are also going to be algorithmic transactions because these are direct debit mandates and things like that, right? Therefore, it is important that there must be an agreed order of the transactions, right? If there are three transactions that I am part of, and the first transaction debited, rather credited 50 rupees in my account, The second transaction credited another 100 rupees in my account, and a third transaction that debited 70 rupees from my account. These three transactions can happen only in one sequence. Just recording the transactions is not sufficient. The order in which they are recorded matters. So the causal, this is what we call as the causal order, or the timing in which those transactions happen, it is important. If 30 rupees was debited, I cannot have another transaction. If 30 rupees was credited, I cannot have a transaction that is debiting 70 rupees immediately, right? I need to have an intermediate transaction where the where the additional 100 rupees was credited to my account before I can debit that 70 rupees, right? So that order is acceptable. The later order is acceptable. The former order is not acceptable, right? So immediately, my system should avoid double spending. Therefore, it should not, if I do not keep a running total of what is my balance, right? I will, and if I think about consolidating these transactions at the end of the day, then this problem of double spending may happen, right? We are with cryptocurrency, we want to prevent this. We do not want our ledgers to be built in such a way that double spending is allowed. So we have to solve the problem of double spending, right? And this is solved by agreeing that there must be an order to the transaction, and the order of the transaction must be global, right? Everybody must agree on that order of transactions so that there is only one single truth, right? There are not multiple variants of the truth, right? So with cryptocurrency, the ledger is the currency. You have to understand that, which means instead of actually having a separate currency or a separate piece of cash that I am carrying around, a separate piece of cash that I am carrying around and doing transactions with the cash. Think of it like I give somebody my entire ledger. If the transaction has to happen, I make a debit and the other person makes a credit in their account, right? That is how, when we are doing a cryptocurrency exchange, we are essentially exchanging the ledgers themselves, right? The ledger is the currency, right? Everybody with me so far? Right? I'll move on. So when you are making a transaction, as we saw in these ledgers, right, a transaction essentially involved two parties and some activity. Right? Now, the owner of the transaction, or whoever is responsible for that particular ledger, is implicitly agreeing to that transaction because they are making that entry. The first party in a transaction is implicitly agreeing by virtue of inserting the record, right? And they are inserting a record about somebody, right? So the second party has to now explicitly agree to the transaction. Otherwise, it will be a breach of trust. Otherwise, the first party can write anything that they want, right? So the second party has to agree that yes, this is the transaction that we need, and therefore they have to give a signature. They have to authenticate the transaction, or they have to give their consent about that particular transaction, right? And this consent is typically given by signatures, right? Typically, when we, when we write a letter and sign it, when we attest a particular letter, that is a signature that we are doing, saying that yes, I am aware of the contents of this letter and I approve of it. That is what the signature really means. Right? Now, when we talk about a digital document, right, there is, if the document itself is an electronic version, the signature does not carry over from the physical world, right? Yes, I can take a picture of my signature and I can put it, but as we all know, in computers we have a Control-C, Control-V function. I can copy image, text, whatever, and I can paste it somewhere else, right? So therefore, A physical, therefore, an electronic or a digitized signature is not reliable because it can be very easily forged. Right. Secondly, because I am inserting the document, the image, a digitized signature on a particular document, uh, if the document itself were to change, then there is no way of guaranteeing that the signature, then there is no way of guaranteeing that the person who signed it approves of the particular document. Right? There's no way of guaranteeing document integrity, right? So the digital signatures have to be slightly different from physical or digitized signatures. Digital signatures have to be publicly verifiable so that they can guarantee the document integrity, right? We have to make sure that, if there are any changes to the document after it was signed, then the signature should no longer be valid, right? That is the requirement we have from a digital signature, right? It must be publicly verifiable, right? So the first part is where we are ensuring that that the signature guarantees document integrity, and the second part, want somebody to verify, but I want them to verify publicly without giving up my own secrets, right? Why this is important? The typical example is that, if I put out, if I have a mailbox and somebody sends me a letter, the mailman should know where to go and deposit that particular letter. My public address is visible, but my private key, which I use to open the mailbox, is something that only I should have, right? It is not, it should not be public knowledge. It should not be public knowledge, right? So the my key is my private key, and my address is my public interface. So here we find that mathematics comes to our help significantly, and there are mathematically provable functions that we can use, which will help us implement these digital signatures. Right? But before that, let me get quickly in terms of what are the desirable conditions from the digital signature itself, right? Typically, we want it to be of fixed length, say of 256 bit length, right? Now, 256 bit sounds too small, right? It is only 256 bits. It's not a very large number. But if we analyze this number, you will quickly realize that 256 bits is a very, very large number, right? To give you an example, it is postulated that the entire known universe has about 2 to the power 85 atoms, right? So even if I had an entire universe to describe every atom of the universe, I would still get to probably about 2 to the power 170, right? That is how large the number 256 bits is. It's a massively, unimaginably large number, right? So finding, two random numbers that that would map into a 256-bit number, it's very, very unlikely, right? With 256-bit numbers, there are certain mathematical operations like prime factorization or elliptic curve cryptography that we can leverage in order to create our public and private keys, right? If I multiply two very large prime numbers, then looking at the product, it is almost impossible for me to refactor them in, right? Looking at a 256-bit number and trying to find the factors of that particular number is not a trivial problem that can be solved with the current levels of computation that we have, right? It is infeasible to derive the private key from the public key, right? Secondly, when a message is now signed, what we do is, we take the digital contents because represented in a computer as in a binary form, right? So if it's in a binary form, then I can create a function, right, which will which ensures that it is a I can compute the message digest essentially, right? It is a representation of the larger message. uh, just like, if we go and ask somebody the time, they may say that it is 3 o'clock today, right? When we ask for time, nobody specifically answers us saying it is 3 p.m. on the 2nd of August 2022 AD. We usually do not get that kind of a response, right? We have the clock kind of acts as a modulo function, and it kind of summarizes the message as saying it is 3 o'clock, right? So similar with message digests, right? Once we create a message digest and encrypt that with the private key, what comes out is essentially my digital signature, right? Because if I now change my message, my message digest would have changed, and therefore re-encrypting it will give me a different number, right? So I take the message, I take my signature, the message digest, my signature. With the creation of digital signatures, we have been able to develop a key distribution protocol, and today we have this public key infrastructure that is available, right? Which allows us to validate the public the public key of the message, right? So how is this done? Typically, a certifying agency like e-mudra, which is a certifying, which is a certification agency licensed under the IT Act, right? They are the ones who are responsible for issuing digital certificates in India, right? And I can approach I can approach e-mudra, ask for a digital signature, and what I will get is my private key that is generated based on my actual KYC, my photos, my passbook details, my Aadhaar card number. All of that are used together in order to create a private key for me, and that private key is put in a USB, in a thumb drive, and sent over to me, right? Or it is available. I mean, I buy a thumb drive, and then I can store the private key on that particular thumb drive. So now, when I'm signing a document, I am going to compute the message digest, and I'm going to encrypt that with my key and send it to a potential recipient, right? How is the signature getting verified? Well, the recipient is going to look at the document, is going to compute the message digest of that particular document, and decrypt it using my public key, not my private key. It's going to decrypt it using my public key that is again available as part of the document itself, right? Once it decrypts, it's going to get or it is going to compare with the document fingerprint that I had that was created when I used my private key by the certifying authority. If they match, then the recipient is guaranteed that the document was signed with the private key. So now I have created the equivalence of a physical signature in the digital world, right? With KYC based, we're doing at public digital signatures, which are based on PAN cards and all of that. In fact, eMudra has been working extensively in order to create this hybrid KYC models with Aadhaar integration, with secure blockchain integration, all of that as well, right? So we have we are, as a country, we are spending national resources on identifying what would work for us in terms of doing KYC with Aadhaar itself, right? If we are deriving a private key based on our biometrics, right, then it is kind of valid for somebody's lifetime. Right? They are carrying their private key with them, and it cannot be replicated ever. Right? So there are certain benefits to using biometrics for that particular purpose. So this leads us to a question: what happens if I have multiple transactions? Well, I have the signing authority who is we have the signing authority who is looking at the particular transaction, and the signing authority essentially says it validates the transaction. But what if this transaction is kind of replayed, right? The transaction would still be valid because the timestamp in it will be valid, right? So instead of allowing an adversary to replay a particular transaction, right, a transaction record, we have built an indigenous protocol called network time protocol, or NTP, right, which ensures that my system clocks are all kind of synchronized with a certain amount of drift that is allowable, right? So every unique ID has to be created and recorded like a timestamp, right? And NTP essentially allows us to create a system of trusted clocks, whenever we today install a particular operating system, whether it is a Linux-based system or a Windows-based system, within its as a default protocol as part of the operating system itself. That is why today, you will find a system time on your laptops, right? It is going to sync up with either the local clock, or it is going to query some other NTP server and get the right number. Same happens with your mobile phones, if you have noticed, right? It will always set to the right time because it's synchronizing with the mobile base stations, right? So this is another way how we can provide security to the transaction that is getting recorded in our ledger. Right? This brings us to the big question that we are here to answer today. How does blockchain address the problem of decentralized consensus? How do people agree? We have all agreed that it would be great if we have the same order of transactions, if we have digital signatures to verify that those transactions were all valid, and if we have a timestamp in them, we cannot change the transactions, right? But how do we ensure that all the parties are seeing the same set of transactions, right? That is the question. That is where blockchain, which was invented as part of Bitcoin, comes to the rescue, and it addresses this very NP hard problem of decentralized consensus. Something, for those of you coming in from a computer science background, this is what we are taught as the Byzantine generals problem, right? So one way to create that trust, right? What if Malak herself cannot be trusted with the ledger, or if she's taking a break, right? So one way of creating security would be to ensure that every member has a copy of the ledger, right? So instead of Mala maintaining every one of the players maintain their own copy of the record. Now, what has happened is the problem of maintaining a secure ledger. This would definitely, if everybody maintains their own copy of the ledger, it is very, very secure. It's very secure because now everybody knows what the right set of records, only if they are informed about the new transactions that are happening in the game, right? Which means that I must have a fundamental level of trust that all transactions are being reported rightly to all the parties, right? And that is where the challenge comes in. by making this assumption that by trusting the system to deliver messages to all parties involved, right, means that there is a intermediary, there is a system which implicitly all the participants need to trust, and that is what can be broken, right? In the case of a macroeconomic shock, we saw how the central bank, which we trust to control the monetary policy and ensure a monetary policy that is consistent for all the citizens across, that is beneficial for the citizens all across, can be a point of failure itself, right? Which is why in a trustless system, if you have to build a trustless system, we need everybody to be able to maintain a copy of the ledger, even if all the messages are not being broadcast properly, right? That's the problem that we have got to solve now, right? Because what is this consensus? The physical act of recording, even before the physical act of recording a transaction on a ledger, right? If the message was lost in translation, it will cause disagreements, right? The reason we have a rent agreement between a tenant and a landlord, right? We try to ensure that we eliminate all grounds for disagreements as much as possible, right? In case of a disagreement, and because disagreements have happened before, if there is a disagreement, the cost to that disagreement is delays and inefficiencies, right? There's going to be a time delay, there's going to be a lot of resources that are going to get used, because over time, because we